Here we go. Distinguishing test, right? So let's do it. So if you look at it, ladies and gentlemen, there's some commonality over here for C, right? This is Rx, this is Rx, and you know what? It's the same Rx, RBR. So you can't do halogenoalkane test on them, yes? Then if you look at this is also the same. This is double bond, this is also double bond, it's also alkene. So if you recall back the previous question, everything that we use there suddenly cannot be used here, can you see? Correct? So if you look at this, so in exam we get stuck. So I'm telling you how we get ourselves out. Look at what I'm doing, huh? So I identify functional group, I say both are Rx. And in fact, both are BR. So there's no way I can test them. I put a cross. Make sense? Oh, so both of them, I cannot, I put a cross. I say, yeah, I cannot do anything to test. Then I have CC double bond. But they are all both CC double bond. So in a way, it seems like I also cannot test them. Then how? Then you need to ask yourself, what is the eventual difference between them? It must be the position of CC double bonds. Agree? This is an angle that I would like to capture for us to solve it. So what is the difference? Is I saw it's a position of double bond. So we're going to aim into the double bond. I realized that if I chop here, correct, and chop here, I would probably get different products and probably different observations. So where are we? We are in alkenes right now. Okay, I'm going to do oxidative cleavage. So what I'm going to do is cleave this. All right, so here we go, oxidative cleavage or strong oxidation. Okay, so what's the procedure? Again, add acidified KMnO4, also known as KMnO4 with H2SO4. And by right, heat with reflux. But again, we don't really need to reflux it. All I need is to see some results. So let me put it into two colors again, the green and the orange. What do you see? Here we go. If you look at it, this group, after you oxidize, will give you this. I slant here because no space. You will get this. Remember the name of this carboxylic acid, very special one, which we discussed last year. Who knows the name? I tell you, you're going to come back and haunt you like nobody business. It's called ethane dioic acid. Yeah, which is very special. Why special? Because it will further oxidize in the oxidizing agent to form CO2 and H2O, which means I already know my observation for the green. Purple KMnO4 will decolorize. And there is effervescence due to CO2. The one in orange color has a 3 carbon. So this is what you get in terms of the carboxylic acid after you undergo oxidation with the oxidizing agent, which will not get further oxidized. Are you with me? So the observation on this side is that it will still use the KMnO4 to get itself oxidized. So purple KMnO4 does get decolorized, but there is no CO2, so no effervescence. Okay, there is a difference here. So one got bubble, one no bubble, you know, yeah, distinguish. Remember, it's not just the answer you want here. All right, answers everywhere, questions is everywhere. What you want is to look at the questions that I've given you, how I start, how I get stuck, how I get out of it and solve it eventually. Because in exam, we will sure get stuck most of the time. So you must have a system to get yourself out of it. All right, in part D, if you look at it, it looks same, but it's different. All right, so it's really about the current topic. So I'm going to go fast on the last one. Ready? Now, if you look at it, this is the same, all right? Or rather, I wouldn't say this is the same. Okay, I don't use color code, right? Ready? Okay, here we go. We know this is called Alkyl Halide, that you cannot touch one, remember? So ask yourself first, Both of them have Br and I. I say, yes, they look the same, but they're not the same. Let's find out what's the difference. By first highlighting this out. These two, you don't touch them because they will never break. There's no chemical reaction for aryl halide. Make sense? They're inert in another way. Yeah? So you don't touch them. So the only thing you can touch them and look at is the green and the orange here. Make sense? Which is alkyl halide. Done already. Okay, see? So what we want to do is to get I minus out, Br minus out. So if you know what's the procedure, we're going to do alkaline hydrolysis. We're going to test for PPT. Is that okay? All right, add NaOH, heat, cool, add nitric acid, add silver nitrate, right? All these you don't have to copy again. You can copy down later on your own, right? It's all the same. So here we go. This one, you will get AgI. So observation, what you see cream PPT of AgI solid, orange color. So I got it wrong. AgI is yellow. All right, this is cream PPT of AgBr. That's it. The difference in color, tell me, I can distinguish it.
If you would like to catch my latest videos, click on subscribe button right now. And click on the bell if you want to receive instant notifications once I've uploaded my latest video. If you would like to join my live chemistry classes and revision workshops, go on to winnerseducation.com and find out how you can score distinction for chemistry on a consistent basis, either in our center or online via Zoom. If you want to check out my online school, go on to passwithdistinction.teachable.com. You'll be able to learn chemistry concepts at your own pace and anywhere in the world, topic by topic. This is Sean Chua from Winners Education, to your distinction in chemistry.